BC.
Awesome. Mic check real quick. Hey everyone, I'm Matthew, one of the co-founders of OpenGradient, and today super excited to talk about decentralized AI. Now, decentralized AI has been kind of the buzzword in crypto for the past year or two, I would say. And for the most part, you see a lot of projects building infrastructure or maybe agents that do things such as transact on-chain and all that. But I wanted to kind of lean a bit more into what exactly decentralized AI infrastructure is actually able to enable downstream now that we've had roughly a year or two of actual building and experience. So a little about me before I dive into some of the interesting use cases that we're seeing in decentralized AI. I'm Matthew, one of the co-founders of OpenGradient, like I'd said. Prior to OpenGradient, I was a research engineer working on machine learning infrastructure as well as modeling infra at 2 Sigma, which is a quant fund, and specifically for the options market making team. Prior to that, I also had some experience doing ML research in the realm of quant finance, as well as in big tech as well. So I guess before we dive into why decentralized AI matters, it's always good to go back to fundamentally why blockchains matter in the first place, right? Blockchains are often called the world computer or the global settlement layer, but more importantly, blockchains matter because people like using this incredibly neutral infrastructure for instant settlement payments where they are also able to custody their own assets, right? You do not have to worry about, bank failure. You also do not have to worry about things such as KYC or, for instance, if you wanted to access your money in a different region of the world, you might be subject to different restrictions depending on where you're from. But the blockchain is agnostic to all of that. You are always able to access all of the crypto or any assets that you own in your wallet, provided that you own the keys to it, and so on and so forth. And similarly, for decentralized AI, we kind of see the same parallels drawn between blockchains and essentially, computing, right? Similar to how people want to custody their own assets, many people want to own their own data, right? They don't want their data stored on servers of huge corporate tech giants. They want their data to remain private, on whatever app that the data is on. In addition to that, they also want to ensure that whenever some model computes over their data, that data isn't being sold or being used for some third-party service or analytics platform, and so on and so forth. And you can see these parallels drawn between this as many, narratives form within decentralized AI. And that's just one of the reasons why we're so excited to continue to develop this infrastructure. So at a glance, DAI offers a couple different properties similar to blockchains. Number one, it's censorship resistant. So you probably have seen some news articles about ChatGPT or Claude not being able to be provided to people who live in China or Hong Kong. And this is a very prime example of what censorship in AI looks like and what DAI is actually able to resolve by providing incredibly neutral infrastructure that anyone can access from anywhere at any time. Secondly is verifiable intelligence. So similar to blockchains, we have these nodes on a network that are able to validate proofs or any attestations that are generated by nodes. So similar to how transactions are validated by all the nodes on the Ethereum network, we can have inferences or other computational work validated on a network to ensure that, hey, the right model was used on the right input data to generate the right output data. And thirdly, we have composable AI primitives. So models, agents, memory, all becoming composable building blocks and Lego pieces that can be pieced together and interop with each other on the blockchain environment. Fourthly, of course, user-owned, like I just mentioned. It's important that people, or many people, feel that they need to own their own data. They do not want their data stored elsewhere. And lastly is autonomous agents. So this is surpassing limitations enforced, such as KYC, and allowing agents to transact freely and also interact with different financial protocols for the most part freely as well. And today, I'm not going to elaborate too much on blockchain limitations, but due to the fact that the EVM, as an example, or the SVM, or many other popular VMs out there are not designed for heavy computation, due to the fact that most nodes on blockchain networks today essentially recompute all the transactions and attest to the state, you can't actually run heavy compute on modern blockchain networks, and that's one of the reasons why we wanted to build a network that was designed from the ground up through novel infrastructure innovation to actually have heavy computation done in TEEs, generate zk-ML proofs, and essentially have this architecture that I'll elaborate on later that allows people to run any sorts of programs and still have the validation and the decentralized properties that I spoke of blockchains. So without diving too deep, this is kind of how the rough infrastructure general layout looks like. We essentially use node specialization. So we have different nodes that are designed to do different tasks. And this way, we can delegate these tasks to specific nodes that are designed to do those tasks. As an example, we have nodes designed to do inference, so these are mostly GPUs. We have nodes that use nitriding in TEs, so this way they can generate attestations that prove that some piece of code was run, that some API was accessed correctly as well. And we also have storage nodes that store, essentially an IPFS fork, that store models. And lastly, we have, of course, blockchain full nodes that validate all the work done by these specialized nodes. This is just a more detailed look of what the data flow is like. Now, diving into the more interesting parts that we're more excited by, which is now that we have the infrastructure and that we've had the infrastructure for quite a while, what are the actual unlocks on the application layer that we can have? And that is a couple examples that we're working on at OpenGradient. Firstly, something that we've been kind of working on for the better half of a year is using machine learning directly in decentralized finance. So one of the use cases that we had was working with Uniswap. We built dynamic fee machine learning models to quote fees for AMM swaps that showcase how machine learning directly on-chain, secured by zk-ML on our network, can actually improve LP profitability. And since then, we've actually built many iterations of these models and are working with teams like Balancer, and we are also building all sorts of other models, including volatility forecasting models, spot forecasting models for decentralized finance protocols. We also have worked with a variety of other different Web3 teams that transcend just decentralized finance. One of them is Filecoin, where we host models that they've developed in collaboration with Repo. So these are AI models that generate some kind of reputation scoring system for miners as well as validators on the Filecoin network. You're able to pass in a set of features representing their uptime and things of the sort, and it can essentially generate some reputation score for that node. So this way they have other external ways of punishing nodes that behave poorly and perform poorly, and rewarding nodes that perform well. And another interesting, exciting use case that we've had, that is also outside of the DeFi realm, is working with teams that are using AI for Sybil prediction. So one of our partners, Pond, actually went and created this AI model that's able to take in a variety of different features for a wallet, and essentially, trace the transactions that it has with other different wallets on the network, and essentially generate a score using a graph neural network on what is the likelihood that this wallet is a Sybil. And I believe they used a lot of open source data from, I think, I want to say they sourced it themselves, plus like some open source data sets on chain or online. But we tested this model out, and it was pretty exciting to see live how it works. And hopefully in the future, when we do our airdrop or some other team does their airdrop, we can use a model like this to try to prevent sibling. And ultimately, this all ties back directly into how we see our infrastructure being used in all these different verticals, right? Not only is it important that these models, these workflows are censorship resistant and verifiable, it's also important that they're easily accessible to the regular user, right? If I run some, if I inference some model or if I run some program, I want to be able to boot up the blockchain explorer and be able to see exactly the details of those transactions. Similar to how if I was transacting and was sending USDC on the Ethereum network to a friend, I might send him the transaction hash and be like, hey, I sent your wallet address here, X amount of money, and here's proof that I didn't cheat you, right? I sent you the right amount of money, and you can use that to prove that you sent money to other people as well. And we've built a kind of custom explorer to fit exactly that purpose, right? You have all these different AI workflows that you can schedule, and you can also see inference transactions where you can query the proof, whether it's like a zk-ML proof or whether it's a TE remote attestation, and be able to actually verify the model, the proof itself if you want to do client-side proving, and the inputs and outputs of the model. So it's completely transparent. And a lot of these AI workflows that you see here, as you can see, the latest results are, I believe, probably arbitrary predictions from different machine learning models that we've built for DeFi. This allows also people to, actually go in and see what the latest predictions are, what the latest forecasts and inferences are for a certain model that is taking in live data and provides an easy avenue for different DeFi protocols downstream to rely on some of these forecasts. And I guess another interesting, and lastly, I think this last example I have here that we've been diving into is if we have TE nodes on our network at OpenGradient, and we are able to actually take advantage of the confidential computing kind of aspect of it, in addition to just simply verifiability on chain. So what are the kind of interesting use cases and exciting things that we could do here? And one thing that we realized would be particularly interesting would be if we could ingest raw user data from different platforms, essentially compute over that in a privacy-preserving way to create vector embeddings for a user that represents their data, right? And this way, they can essentially have privately secured memories powered by AI. And that's kind of what we did with this product we call MemSync. We did build the library for memory from the ground up as well, but this is all powered by TE nodes on our network where you can connect your LinkedIn, your X, different documents, your ChatGPT history, your Reddit account, and essentially pulls all of your data, turns that into vector embeddings. But in addition to that, it also does PII redacting. So it looks through your data, finds the things that you probably want to hold private or probably don't want to share, and redacts that and turns that into a vector database that you can use with different LLM providers. And this way, you can provide your data to these providers while ensuring that the raw data itself is actually not directly exposed to third-party apps or other servers, and maintains complete confidentiality. And on top of that, we also started building digital twin features, which allow people to not just take their data and plug it into different LLMs, but also generate essentially digital replicas that hold certain pieces of their personality depending on how you customize it. And you can make that digital twin accessible to other people, so you can share your expertise, share your personality, all based off the data that you expose to the digital twin. This is just a simple, okay, well, I guess maybe this is not playing, but this was supposed to be a demo of some of the prompt injecting kind of features of MemSync. So we built an extension that would allow you to essentially one-click inject relevant context into existing LLM platforms as well. So as an example, if I am in a vid, I guess ice cream connoisseur, I can ask, hey, what are the best ice cream shops around here? And it can inject some context saying, oh, Matthew's favorite ice cream is mint chocolate chip, and he's also interested in frozen yogurt as well. And it can automatically take that context and run a more relevant and powerful query that suits my interests. Yeah, this is all, again, just meant to showcase exactly what verifiable, confidential AI can do, powered by our infrastructure. And we've also been experimenting directly downstream of all the DeFi models that I spoke of by building our own end-to-end on-chain AI agent that currently is plugged into, I think, Solana, Base, Sui, and maybe Ethereum. And people can navigate to bitquant.io and be able to ask them questions about their portfolio. They can connect their wallets, and all of this is, again, secured end-to-end by our infrastructure. Every inference is verifiable on our blockchain explorer, and you can see exactly what model it is running. And you can also see, that this is using essentially the right model to generate the different results that you get here. And of course, it's also integrated to different DeFi protocols, so you can directly swap or stake or pool your assets with a lot of the supported protocols that we have on BitQuant. So yeah, now that I've covered all these, this array of interesting use cases that we're kind of interesting, that we find interesting and are currently developing, the next step that we see for this is how do we develop the infrastructure, the tooling, how do we develop all of this to make it easier, not just for us, but for third-party developers or other corporations and startups to come in and use our infrastructure to build all these apps and agents. And with that comes, obviously, a multifaceted challenge, right? It's not just simply using inference, right? It's how do we use, as an example, some SDK to upload our model to your decentralized file store. Okay, well, if we want to build, let's say, a more complex application that requires different data sources, it's not just inference, then how would we use that with your blockchain tech? Well, we had to build multiple kind of pieces of technology to make this work, including our own SDK, our own boilerplate agent library that people can use, as well as ship a lot of other, I guess, like boilerplate code for people to launch a variety of different applications that use either data feeds securely or use model inference or use different data pipelines that we've built into our network. And one of those that we wanted to highlight was the Model Hub, which is, I believe, today the largest decentralized repository of AI models available. A lot of them are actually specific to Web3. So this is an older screenshot, but I think today we have maybe around 1 to 1,200 models. A lot of them are ML models that we built or our partners have built specifically for Web3 and DeFi purposes. All the models that I cited in previous examples, you'll be able to find on our Model Hub as well. And the Model Hub, again, is designed to provide censorship-resistant access powered by the decentralized file store to any of these models uploaded. And you can actually go to the Model Hub, live inference any of these models. You can download it. We have model versioning as well. And yeah, we host models for Pond, for Sentient, for a lot of other bigger decentralized AI partners. Yeah, super exciting to continue to develop this and see more models being uploaded. We're now focused not just on Web3 models, but also onboarding more traditional models that people might want. As an example, recent requests, we've gone our vector embedding models, and we've stolen them from Hugging Face and Kaggle for the most part to provide our clients. But if you wanted to upload any model, it's of course very, very easy as well. We've built a lot of surrounding tooling for that. And the ultimate vision of building all this decentralized AI infrastructure, I know I've thrown a lot of different interesting and exciting use cases that we're working on at you guys today, but ultimately is to bring AI on-chain. We think that there is a world where essentially every inference is routed through a network that is able to provide some attestation. And you see a lot of concerns about this being raised in Web 2 as well. As an example, recently with Cursor, people were complaining about the fact that some of these models in Cursor started reasoning in Chinese. It's because I think they were using some of the cheaper and more cost-effective Chinese models, which, I mean, if you look at the token cost for a lot of these frontier LLM providers in the US, I totally understand why they would do that. But if you don't want your data exposed to Chinese servers, then these attestations could be very, very important, right? If you are exposing your personal data, you might also want to have the applications and agents you're interacting with be able to expose the transaction, or transaction hash or a link that you can click on, and you can see that, hey, your data wasn't exposed, it wasn't stored anywhere else, or it was run through this program that does exactly this. And in addition to that, of course, continuing to productize research and ensuring that all this infrastructure, all this tooling, all the models that we're building actually sees the light of day downstream and are integrated into different, both Web3 and Web 2 ideally applications. And ultimately, we want to be able to see these kind of modeling and AI development verticals take off. And overall, we're super excited and super bullish on decentralized AI. I think today, most people still don't necessarily, or probably still choose the most cost-effective and straightforward option, which is directly using LLM provider APIs. But we think, again, over time, as more of these scandals come up, that there will be an increasing discussion around whether it makes sense, or how much money does it cost to actually provide this verifiability, to provide users with peace of mind. And ultimately, we're super excited to be building infrastructure that supports just that. Yeah, just a quick screenshot of some of the core contributors of our team. And that's it. Thank you so much.